Hello everyone and welcome in a new video, and in this video we are understand the concept of SJF scheduling algorithm. SJF means shortest job first. Okay, if you watch my previous video about a conway effect, then you definitely understand the importance of SJF. Okay, so now we are going to understand that what is SJF. In SJF, what going to happen is, what is the scheduling criteria is basically the scheduling criteria. SC means scheduling criteria. Okay, so the scheduling criteria in the shortest job first is that whosoever process have a smallest burst time will get the CPU first. Okay, not like in FCFS where we depend on an arrival time. Here we depend on a burst time. Okay, so this is like CPU and this is our ready queue. So if like P1, P2, P3 and P4, let's say we have 4 processes. Now burst time is like 5, burst time is 10, burst time is 1 and the burst time is 2. So and the sequence of arrival time is like 0 0 0 0 means all the processes. This is burst time, this is arrival time. 0 means all the processes are available to get a CPU. Now whosoever process have a smallest burst time will get the CPU first. This is what the scheduling criteria of shortest job first. Okay, so here which process have a smallest burst time? So process number 3, P3 is basically a smallest burst time. So P3 is a process who get a CPU first. After P3, P4 is a process who get a CPU. After P4, P1 is a process who get a CPU. After P1, P2 is a process who will get a CPU. Not like the sequence like in what we do in FCFS is, first of all we select P1, then P2, P3, P4. This thing is not happen in SJF. Whosoever is the smallest burst time will get the CPU first. This is what a scheduling criteria of shortest job first. So process with the smallest burst time will schedule first. So processes with smallest burst time will get the CPU first. Will get CPU first. Will get CPU first. This is what a scheduling criteria of shortest job first. Okay, and after that what we have to do is we have to understand about there is no condition for a tie. So like what happen if there is a tie between the burst time. Let's say the burst time of P3 process is also 2. So now which process will get a first, P3 or a P4? So definitely P3 is a process who will get first. Why? Because of the sequence. If there is a burst time, there is a tie between the burst time, then we select that process whose the ID is minimum. So here you can see that 3 is less than 4. So definitely we select P3 rather than P4. Okay, so this situation same occur in FCFS as well, when there is a tie between an arrival time. So whose process has a minimum ID will get the CPU. Okay, so this same thing is also happen in the SJF as well. Okay, so when the tie, then we have to select the process whose process ID is minimum. Okay, the same thing that we do in an FCFS as well. Okay, so after that what we have to do is, what kind of scheduling algorithm is this? This scheduling algorithm is of non-preemptive type. Non-preemptive type. What is the meaning of a non-preemptive? Non-preemptive means a process cannot leave a CPU by an external force. Process can only leave a CPU when it execute fully, or when it's terminate, then only process leave a CPU. Operating system cannot forcefully take CPU from the running process. Okay, so this is what the meaning of a non-preemptive thing. So this is what a basic intro of SJF. Now we solve some numerical on this, and that part is very important because in a gate point, for the gate point of view or for the college exam point of view, these thing is important. Okay, so process is like we have take 3 process, P1, P2, P3. Arrival time is 0 0 0. Every process is available. Burst time is 20. Now we take the same process like 25 5 5. The same thing we do in a FCFS as well. We select the same question. Now Why we select the same question? Because we are going to compare the average turnaround time and average waiting time, that there is a change in between these two algorithm, or there is change or not. Okay, we are going to see this thing. Okay, now solve this question. What we need? Completion time, turnaround time, and the waiting time to find the average of waiting and TAT. For that, what we have to do is we have to make a Gantt chart. So how we make a Gantt chart? This is our process 0. At 0 all the processes are available, P1, P2, P3, all the processes are available, but which process we gonna select? We are going to select who have a smallest burst time. So here and P2 and P3, both the process have a smallest burst time and the same burst time. So when there is a tie between the BT, then what we have to do is we have to select the process whose ID is minimum. Okay, so between 2 and 3, definitely 2 is smaller, so P2 is a process who gets selected first, and the completion time, burst time is what? 5. So the completion time of P2 is all what? 5. After that, P3 process is gonna select, completion time is 5, so the completion time of P3 will become 10, the completion of P2 plus the burst time. After that, P1 process, so 25 plus 10 is become 35. So the completion time of P1 is 35, for the P2 is 5, and for the P3 is 10. TAT. TAT means turnaround time. What is the formula to find out the turnaround time? Completion time minus the arrival time. What is the TAT? TAT means the process, how much time basically the process is spent in a CPU. So 35 minus 0 become 35, 5 minus 0 become 5, and 10 minus 0 become 10. Waiting time. Waiting time is what? Turnaround time minus the burst time, so it becomes 10, 0, 5. Okay, now we have to find the average turnaround time. So the average turnaround time is what? 35 plus 5 plus 10 divided by 3, so it becomes 40 plus 1, 50. 50 divided by 3, 50 divided by 3 is 3 1 3, 5, 20, 6. So 16.6 is average turnaround time for these processes in SJF scheduling algorithm, and average of waiting time is 10 plus 0 plus 5 divided by 3, so you do is like 15 by 3, so 5 is what? Average waiting time in this case. Okay, so when we solve this question with SJF, so the average turnaround time is 16.6 and average waiting time is 5. Now when we solve this question with the help of FCF scheduling algorithm, this is the same question. What is the average turnaround time? The average turnaround time is what? 30. Average turnaround time is what? 30. So here you can see that how much drop of average turnaround time is seen in SJF scheduling algorithm. What does that mean? That means that shortest job first scheduling algorithm is better than FCFS scheduling algorithm. Okay, and average waiting time is what? 18.03, and average waiting time in SJF is what? 5. So here you can see that there is a very high decline of a average TAT in waiting time, so definitely SJF is better than FCFS. Okay, so this is what, and we need this thing because the main goal is what of scheduling, CPU scheduling, is that we have to get minimum TAT and minimum waiting time for the processes. Okay, whosoever scheduling algorithm will give, and when we apply that scheduling algorithm in any system, that system will definitely become powerful. Okay, that powerful in the sense that system will move fast, that system will done the process execution very fast. Okay, so this is what SJF scheduling algorithm, this is how SJF scheduling algorithm works. Now we are going to solve one more question, and then that's it. Process, we have a process P1, P2, P3, P4, P5, P6, P7. We are going to select 7 processes. Arrival time is like 0, 1, 2, 3, like 4, 5, 6, 8, and burst time is 6, 3, 4, 2, 1, 5, 2. Now what we have to do is we have to find the average TAT and average waiting time. So for that, completion time we have to find, TAT we have to find, and WT we have to find. Okay, and for that what we have to do, we have to make a Gantt chart. So when there is a 0 arrival time, how many processes are available at 0? Only one process is P1. Okay, now remember one thing, that we are place a process with the seeing the arrival time. Okay, we see an example like we are playing a cricket in a ground and one player is at home and your team is gonna bat first. So that player is at home, then how that player will then the player can able to bat? So the definitely answer is no. So this is what cases happen here as well. If there is at 0, if there is one process, then that process will get a CPU. If at a particular arrival time we have no processes available in a ready queue, then CPU will become an idle. Okay, so at 0 only one process is available, which is P1. We see burst time after seeing the arrival time. Okay, in SJF or in any scheduling algorithm. After that, why P1 selected? Because of AT. Burst time is what? 6. But this is a non-preemptive, so whole process will run at a go, in a one go. Okay, so P1 0 to 6. After that, at 6, now how many processes are available? P2, P3, P4, P5 and P6. So 5 processes are now available to execute. Now whose process will get a CPU? Now we are going to see the burst time. Now we are going to select a burst time. Okay, because now we have more than one process, so definitely what does that mean? That means we are more than one player to bat, but we are going to send that player, we are going to send that process who's having a smallest burst time. So in this case P5 is a process who have a very smallest burst time among these 5, so definitely P5 will get a CPU. And what is his burst time? Burst time is 1, so the completion time will become 7. After that 7, these the P5 is done, so only 4 processes are left. P7 is not included. Why? Because its arrival time is 8 and we are at a 7. This player is at home right now. Okay, so we cannot move P2 to execute. Okay, so after that, among these 4 which have a smallest burst time will get a CPU. So among these 4, P4 is a process who have a smallest burst time, so P4 will get a CPU, and the burst time is 2, so 7 and 2 is 9, and P4 is also done. Okay, now P7 is in a queue, so we can choose P7 as well. So at 9 arrival time, P7, P6, P3 and P2, 4 processes are available. Which process will get a CPU? P7. Why P7? Because of the burst time. He is having a smallest burst time, which is 2, and P6 having 5, P3 having 4 and P2 having 3. So definitely P7 have a smallest burst time. So we are selecting this. So 9 and 2 is becoming 11. So after that P7 is also done. Only 3 processes left. So definitely we select P2 because of a smallest burst time. Burst time is what? 3. So 11 and 3 it become 14. It become 14. So P2 process is also done. 2 processes left, P3 and P6. P3 will select because P3 having a P3 having a smallest burst time. What is the burst time? Burst time is 4. So 14 and 4 become 18. 14 and 4 become 18, and P3 is also done. After that, one process left, which is P6. So P6 will get a CPU, and burst time is what? 5. So 18 plus 5 become 23. So this is how the Gantt chart will form in SJF. Remember this thing. First of all, we see with the arrival time. So at 0 only one process. Then whatever its burst time is, we are going to select that thing, because we are only one player in our team who are going to bat. Okay, so this is like that. Okay, every player is right now at home. Only P1 is a player who is in a ground, so definitely P1 goes to bat. Okay, P1 will go to bat. So this is the situation in SJF. Okay, at 0 P1. After that, all the processes are available. 5 processes are available. Now we are seeing the burst time. Whosoever is the smallest burst time will get a CPU. This is what happened in SJF. In FCFS, what happen? Whosoever is the smallest arrival time will get a CPU. Okay, in SJF, whosoever is the smallest burst time will get a CPU. Now the completion time. So for P1 completion time is 6, P2 completion time is 14, P3 is become 18, P3 P4 9, P5 8 7, P6 become 23. Okay, so for P6 is 23 and P7 it's 11. Average TAT is what? Completion time minus arrival time. So 6 minus 0 6, 14 minus 1 13, 18 minus 2 16, and 9 minus 4 5, 7 minus 3 2, 23 minus 6 17, 11 minus 8 is 3. Now waiting time, which is TAT minus burst time, turnaround time minus burst time. Waiting time is how much time process wait for IO event or for any reason, how much time is process are going to wait in a CPU. So this is what a waiting time is. So 6 minus 6 0 means P1 is waiting for wait for nothing, because P1 is a process who execute first, so definitely its waiting time will 0. After that 13 minus 3 10, 16 minus 4 is 12, and then 3, and then 2 minus 1 is 1, and then 17 5 is 12 and 1. So this situation is like this: 0 10 12 3 1 and 2 1 12 and 1. This is what a waiting time is look like. Now average of turnaround time, so you have to calculate the average turnaround time. What is 6 12 14 and 3 17 and 7, and yeah, you definitely comment down the average turnaround time of this thing and average waiting time of this thing. Okay, so it's very simple. What you have to do is you have to sum all the TAT and divide it by 7, sum all the waiting time and divide it by 7. Okay, so this thing you can done by yourself. This is your work. Comment down whatever your answer is. Okay, this is what SJF scheduling algorithm, SJF scheduling algorithm, which is shortest job first scheduling algorithm. Okay, so I hope you understand this thing, and I hope you understand that why I choose P1 first, because at arrival time 0 only one process is available, that's why I choose P1. Among these 5, why I choose the 6th among these processes, why I select a one particular P5, because of burst time. Now when so many processes are available, we choose according to the burst time. Okay, so this is what SJF is. Thank you for watching the video. Like the video and subscribe my channel, and definitely comment down your answer.